Okay, so let's do the quiz 8 first. Even though it's, it's included in the previous test, but it's somewhat related to what we're going to do in chapter 8 and 9, quiz 9 and 10. So I'm going to just go over this really quick. So, first question. So the local gas station wait 4 days to receive. Did we talk about this already? No. So 4 days to receive delivery of regular gasoline. I think we talked about something similar. And then the wait period to receive is what we call lead time. So the demand during the lead time during those 4 days, in average, it's 930 gallons. And then there's a standard deviation of 140. So the probability, we want to know what's the probability that the next lead time, during the next lead time, the demand for regular gasoline will be less than 800. So, and so if we draw normal distribution, this is the mean, so it will be 930. And then the standard deviation will be 140. Want to convert, and then we want to know 800. What is this area, right? Whatever less than this area. Okay. So the first question A, B, I mean 1A, 1A, A is the z-score of 800 will be equal to 800 minus 930 divided by the standard deviation, 140. Okay, so this will be negative 0.93. And when we look up the probability on the z distribution table, when this is equal to negative 0.9, area is equal to, probability is 0.1762. Okay. And then the second one will be 1000 here. So instead of calculating this area, now the 1000 will be the demand less than 1000 will be this area. Okay, so try the printer. Yeah.
I print one out, you saying?
Yeah. You want what kind of paper?
I want it, I just print one out.
So you want this quiz?
Yeah.
It's in my office, just a second. We already gave out the quiz long time ago. So 1000 will be D 1000 equal to 1000 minus 930 divided 140. It will be 0.5. Divided by 140, that's 0.5. It's 915. Okay, so that will be that. How about C? The possibility that the demand will be equal to 900. Just here. What would that be? In this case, because this is a continuous distribution possibility, so when this to be exact equal to 900, the possibility we can say 0. Okay. And then the station manager places the next order when the inventory is 1200. What's the possibility that the station will not run out of gas? So 1,200 is here. Okay, so the possibility that they will not run out of gas will be somewhere here, right? As long as it's less than 1,200, they won't run out of gas. So it will be 1,200 minus 930 divided by 140, which is, that's the Z. The Z is 1.93. And P for that will be 0.9732. Okay, so that will be the possibility we will run out of the gasoline. And then the E. So what would be the reorder point? If we want to have 90% of the possibility that we will have enough gas. So we want this area to be 10%. And this area will be 90%. So this is one tail, okay, one tail. So when this happens, the Z is what? When we want the 10% alpha, it will be 1.68. Can you see that? Oh no, 1.28. Oops. So Z is 1.28 when we have one tail, 90%. 1.28. So it will be 930, 930 plus 1.28 times the standard deviation, which is 140. So that will be, and read that, 1129.2. So that will be E. So if we want to have 90% of chance that we'll have enough gas, when the gas is at this point, we need to reorder. And then it will take 4 days. And this will keep going down until it reaches to 0. We'll have enough gas. So let me go get I don't know if I have it. Let me go get the quiz A9 again. I don't think I have 8. I have 9. Maybe.
What is that one? What does that say?
So 1,129.
1,122. Christ. Gosh.
Okay. This 8, 9, and 10. Thank you very much. Do you have it? You have it? 8, 9, and 10. So let's finish quiz 8, number 1. Okay. Now let's move to number 2. So the average pure I mean for 2013 Ford Max Hybrid, 39.2 per gallon. Standard deviation 3.7. So assuming whatever they need the gas, it's follow the normal distribution. So what would be the confidence interval? When we have 68%, we want it to be accurate, 68%. So we know 68 is what? 1, right? So basically, here, basically is 30. $39, so it's the confidence interval will be mu plus minus the margin of error, right? Yeah, margin of error. Margin of error is sigma times the z. So when this is 68, the z is 1. So this will be 39.2 plus or minus 1 times 3.7. Okay, so the confidence interval of 68% will be 35.5 to 42.9. That's the first one. Second one, 39.2 plus minus 2 times 3.7. Right? Yeah. 31.8 to 46.6. 99.7 is 3. The z will be 3. So 39.2 plus minus 3 times 3. 28.12. 3. Any questions? So if the company want to be accurate about what they say, they could say the MPG for this car is around 28.1 to 50.3, and we have maybe there will be 3%, 0.3% of chance that we made a mistake. So that's what they can say. Or they can say it will be between 31.8 to 46.6. And they have 5% of chance that this might be wrong. Okay, so that's question 2. Let me erase this. Question 3, Wall Street Journal. They study NFL and found out the average play time was only 10.7 minutes per game during the actual playing time. Okay. So assuming the actual playing time follow the normal distribution and then the standard deviation is 0.8 minutes. So what's the probability that the play will be between 9.8 minutes to 11.9? So I just draw this. So I personally like to draw, like whenever I draw something out, it will help me to understand. So the average actual playing time is 10.7. So the first one, we want to know the probability between 8 and then 11.9. So we want to know the probability here. Okay. The reason you need to draw this is because if you have a chart, it depends on what kind of chart you get. Okay? I'll explain it later. Let's calculate the z-score first. So we have to convert this to z. So the first part is 11.9 minus 10.7 divided by standard deviation 0.8. The z will be 1.5. And then second part, 9.8 minus 10.7 divided by 0.8. The z will be negative 1.13. Okay. So now let's go back. Let's go find a table. I'll show you what I mean. So the table. So if we see, let's use. So this is the Z table. And then you see here, they will give you, how should I put it? The Z-score, okay? So from this one, it actually give you the negative one, okay? Because it's on this side. So what we do is, we can find out about this one first, so negative 1.13. So let's find negative 1.13, which is negative 1.1, and then 1.10, 111, 11, 112, 1.13. Negative 1.13 is here. So it's 0.1292. Okay? 0.1292. Go back here, 1292. So it's here, right here. So it means this area. Change to Vietnam. So that means you can come here. So that means this area is 0.1292, right? Yeah, 0.1292, this area. Okay, and then let's figure out this one, 11.9. So with that table, we don't have positive one, we only have negative one. So we can find a negative 1.5. So it's symmetric. So negative 1.5 is, I wouldn't say the same, so 1.5 here, and then negative 1.5 is here. So whatever is here, the area here will be the same as this area. So we have to kind of convert it, okay? So we have to use 1 minus this area, and then we get this whole area. And then we use this area minus this area, okay? That's the table we get. But if I have another table, let me find another table. So it depends on whatever table we get. So if I use this table, okay? You see this table show us the positive number, and it shows us the whole, oh, this is also negative. Oh, this one is positive. So we just need to find a positive 1.5. So it's here, 9332. Okay, so you see this one, it tells you the whole area, 9332. 1.5, yeah, 9332. So this means change another color. This means this area is what? 0.9332. Okay. Now let's go back to question. So you see here, what we want is the area in the middle. We use pink. So we want to know this area. Oops. We want this area. So we have to use 9332 minus this. Okay, so what we got is 408.804 will be this area. 0.804. Okay. Any questions? So, yeah.
I did that, but in Excel, and I got slightly different numbers.
Yeah, because Excel doesn't round it up. So we can also use Excel. I'll use Excel to do number B, 3B, okay? So when we use Excel, B, just draw here. So B is a little bit different because the average is 10.7. So this one will be 11 here and then 12.1. So B is in this area, okay? And what we can do is we can use Excel. We just pull up Excel. So when we use Excel, what do we use? The function we use is norm distribution, right? Because it's normal distribution. So X is the number in the front. And we want, in this case, we want 12.1 in the front because 12.1 is bigger. So we want to do 12.1, that's X, and our mu is 10.7. And then the standard deviation is 0.8, right? And we want it to be cumulative because we want the whole area. We want, like I draw, we want the area here, okay, 11 to 12.1. We want the whole area. So we put in true. So that's the first number. So that will be 12.1. Possibility 0.9599. Okay. And then the second number will be, just copy this. So I'll just change this number to be what? 11.11. 11. It's 11. So this will be the number. And then the possibility will be this minus this. Okay. When we use the chart, it will be something different. So what we can do here, we can also copy the whole thing over. And then I can change, I'm going to change it to the previous question, just to see if your number is, so it's 11.9, first one. And then the second number is 9.8. So it's 0.8029. And what we calculate is 0.804. Okay, so this should be okay too.
Okay.
And then C. Let me copy again. B is here. A is here. So I'm going to move this. Let me see what I can do. Just move this here. And then move the whole thing here. And then copy. So let's do C. Copy C over. So C will be 9.7 to 10.3. So the first one is 10.3. And then the second one will be 9.7. So answer for C is this one. 0.2029. Any question? No? Okay. So now let's do question 4. Okay, so I'll just put question 4 here. So question 4 says use Excel. But when you do tests or quiz, you can always use Excel. But like I say, if you don't show your calculation, you just do Excel. If your number is very off, then I can save you, I can give you partial credit, okay? But if you show some calculation and you made a mistake in calculating the stuff, you can still get partial credit. So there are pros and cons. Excel much easier, but if you accidentally type something wrong, then that's it, okay? So so number 4, we do norm distribution. So first one, those program claim the average weight people lose during the first 2 weeks is 5 pounds. Assuming weight loss follow normal distribution, standard deviation of 3. So what's the possibility that someone lose less than 7 pounds after 2 weeks? So 7 pounds under, okay? So it's just the X will be 7, and then the mean will be 5, and the distribution will be 3, and then 2, right? Cumulative. So this will be the possibility, which is 0.7475, close to 75%. People lost less than 7 pounds. Excuse me. So people gain weight after 2 weeks. Okay, so people gain weight means they don't lose anything, 0 or below, right? So it'll be 0 and then below. So the formula, the X will be 0. So we just need to change this to 0. The average is still 5 pounds per every 2 weeks. 3 pounds is standard deviation, and then true. So the people that would gain weight is 5% of chance. Okay. How about the possibility that people lose between 1 and 4? So again, let me copy this. Okay. So the reason I do that is so I can put 4 here. And then I'm going to put 1 here. So possibility lose 4 pounds will be 30, almost 37%. Possibility lose 1 pound or less, 9%. So we just use this minus this. 27.82% of chance people lose between 1 and 4 pounds. So that's quiz 8. Any questions? If not, let's continue. Quiz 9. So quiz 9, first question. So quiz 9 is a little bit different because quiz 9, we are doing the point estimation. So we actually have sample. So when we have a sample, we have to adjust the sample standard deviation we have to convert the population standard deviation to the sample standard deviation, okay? So the only difference is we have to convert that. So let me write it. So the population standard deviation sigma equal to 39. And now we want to calculate this one. To be 39 divided by the sample size, which is 35 hotel. Okay, so the sample size is 35. So this would be 39 divided by your 5.92. So the sample standard deviation is 6.59. And we want 90% confidence interval to estimate the average room rate. So it will be the X bar or mu plus minus this times the Z. D is when confidence interval is
1.645.
1.645 to 0.645. So this, and then this will be, this part will be 10.84. So plus minus 10.84, this will be 236.96, 258. First one. So second one, very similar. The only difference is the sigma X bar, okay? Because now the standard deviation is 63, and then this for first one only 30 sample size divided by 30 square root. So the first one would be 11.5. The second one is 63 divided by 60 square root, the square root of 60. So it will be 8.13. Okay, so the A will be 507 plus minus 1.645 times 11.5. Right? Yeah. So this will be, this part is 18.92. So we want to calculate the margin of error. So margin of error for A is 18.92. So this Z times the sample standard deviation, 18.92. And then the confidence interval will be 507 plus minus 18.92, which will be 4.08.08 to 525.92. A. B will be the margin of error will be 1.645 times 8.13. Be 13.37. So it will be 507 plus minus 13.37. And the answer will be 493. 451.37. So what impact does increased sample size have on the provision of this estimate?
It decreases the margin of error. You increase the sample size, it increases.
Yes, when you increase the sample size, the margin of error will decrease. Because we divide this by sample size square root, okay? So that's why we say when the sample size is bigger, it's closer to the population. Yeah. So you see, when you increase the sample size, the margin of error is decreased, and then the interval, confidence interval become a little bit narrow. So question 3 and 4. 3. Or I have sore throat, so kept drinking hot water.
Sorry, what was C again for the first one?
First one, is when the sample size is larger, the estimate will be smaller, narrower, because the margin of error becomes smaller. So, for this one, they want to check the wait time for method. The population standard deviation of the wait time is 4.1 minutes, and then they select 5 random samples. Each has around 30 different wait time, and then those are the average of those wait times. So those are 12.4, 11.3, 13.1, 13.7, 12.7. So 80% confidence interval for each sample. Because the so then the margin of error is different, right? So let me put it this way. Well, Twelve point four, 13.1, 13.3. Okay, so we want to determine 80% confidence interval for each of these samples. So the 30% confidence interval will be, we want 80%, right? 80%. So 80%, what is the z-score? This will be 210. 1.28, okay? So the standard deviation of the sample will be 4.1 divided by 30 square root. So that would be 0.748. This is the first. And then the margin of error will be 1.28 times this. So it will be 0.957. No, this is part of A. So we need to plus minus this to all the 5 samples. Okay. So 12.4 plus minus 0.957 will be 11.42. Yeah. And then for this one, 10.34. 0.26. Third one, 12.74. 12.74. 66. 1.74. 13.66. So these are the confidence interval. Assuming the actual average wait time for all customers is 13 minutes, are these results consistent with the definition of 80% confidence interval? So we want our average to be in 13 minutes. So which one doesn't have 13 in their confidence interval? Or all of them as 13. Yeah.
11.53.
So the second one, right? And because 13 is like out of the range. So this one does not consistent with the definition of 80% confidence interval. Okay, so the second sample.
The answer is just the second one of those.
Yeah. So the second one is not consistent. So this means we either need to change, adjust our average wait time, or we need to adjust our process. So the fourth question. The crisis in the housing market. Led to lower vacancy rate, and then it actually lead to increase of monthly rate. Suppose the random sample 40 apartment have average rent of $1,090. What's the standard deviation? And then the standard deviation of population is $260. So 80% confidence interval will be. So let's calculate the margin of error first. So margin of error, 80%, two side, two tails. So basically they want to calculate withdrawal. So this is 1090. Okay. And then they want to calculate this and this so that this area is 80%. Okay. So this is 1090 plus minus 1.28 times this 260 divided by sample size, which is 40. Okay, that's 8. And then the answer will be 1142.66. Step B will be, write it down. Plus minus 1.96, 95% two tail times this same thing. So this is, so the answer will be 0.372. This will be the B. And then D, we see 98%, the Z will be 2.33. So this one will be this plus minus 0.33 times 1.31. That's quiz 9. Any questions? Okay. So now let's go to quiz 10. Did I talk too fast? Okay, good. So quiz 10. First question is relatively easy. We just want to identify the null hypothesis and alternative hypothesis. So first one, IRS, I want to see the effort of trying to encourage people file tax online, whether or not it's successful. Okay, so they want to see if the proportion people plan to do e-file to be exceed 70%. So that means the null hypothesis will be what? What do we say about the null hypothesis? The null hypothesis have to have equal sign, right? So the proportion of people that file e-text, because they want to test if it will exceed 70%. So the status quo is it's less than 70%. So P will be less equal to 0.7. That's the null hypothesis. And we want to actually try to reject this one so that this is our alternative hypothesis. P is actually greater than 70%, 0.7. So they want to show that, okay, their effort works. That's first one. Second one, also the plan properly for equipment service during upcoming year. The Comcast, they want to see the hypothesis. Average number of television in a home, the customer equal to 2.9. So this is, they want to see whether or not it's equal to 2.9. So the status quo is the average, the mu is equal to 2.9 average TV in a household. And then the null hypothesis is it is not equal to 2.9. That's it. And then the third one, federal government want to know the effectiveness of the recent tax break for first-time home buyer. So before the tax break, average period of time a house on market was 60 days. And the government want to know the plan that the average time on the market now is less than 60 days. So the alternative hypothesis is the mu is less than 60 days, right? So the null hypothesis would be, oops, greater or equal. To pick up my daughter when I'm home. Yeah, so this is ABC. Any questions? Okay, now let's move on to test the hypothesis. Okay. So Lindsay is the manager of local Ruby Tuesday restaurant. They implemented changes to their operation to reduce average wait time for table between 6 p.m. to 8 p.m. on Saturday night to less than 20 minutes. So now we want to see. So our hypothesis is to test. Okay, so the null hypothesis, oops. I haven't finished reading the question yet, but I just want to show you the first step will be to decide our hypothesis. So the first step is to decide a hypothesis. The null hypothesis is mu will be greater, equal 20 minutes. Okay, wait time. So the alternative hypothesis is mu will be smaller than 20 minutes. Okay. So if I draw this 20 minutes, and we want to know the alpha is 0.5. So this is one tail. Okay, we want wait. Oh yeah. So we want to know the 18.3, the average wait time that took sample. Is this outside of range? Is this belong to this area? Okay. So the second, she want to do that, and then the standard deviation for this is 5 minutes. Okay, so sigma is 5 minutes, and the X bar is 18.3%, 18.3 minutes. And then the alpha is 0.05. So we want to calculate the z-score. So the critical z here, when this area is 0.05, what's the z-score? So this area has to be 95%. This is 0.05. So this is negative 1.645. Okay, for one tail, alpha equal to 5. This area is only 5%, 0.05. So alpha is 0.05. Z will be negative 1.645. One tail. So the Z for X bar be X bar minus mu divided by this. It will be 18.3 minus 20 divided by 5 over square root of 45. Negative 1.7 divided by 0.745. So the Z X bar will be negative 2.28. So the critical Z is 1 point. So here is 1.645. And then this is negative 2.28. Is it here in this area or in this area? Is it in area 1 or in area 2? It's 1. So do we reject the null hypothesis? Yeah, so we reject the null hypothesis. That means the mu is actually statistically significant, less than 20 minutes. So they actually improve the wait time, okay, to less than 20 minutes. Any question? So similar, same question, but instead of using the Z, now we use the P, okay? So we were calculating the Z, but now we calculate this area, the P value of the previous example. So the same thing, we already calculated Z equal to negative 2.28. So the proportion of Z equal to negative 2.28 will be 0.0113. Okay, and we only want alpha to be 0.05. So this is 0.05 and 0.0113 is smaller in here. So it's in this area. So from here, we also reject the null hypothesis. Okay, P less than alpha. Any questions? Okay. That's it. End of semester. For me, well, I need to grade your test. You need to do the test. So I got some emails saying that they are behind. So if you know, so everything is due by May 5th, midnight. If you cannot finish everything by May 5th, please send me an email and I will give you an incomplete. So you have more time to finish everything, but don't forget, try to finish by the end of summer. In theory, when you have an incomplete, we don't need to change anything until the end of fall semester, like December 15th. But you know, when fall starts, you have new stuff. So if you are not taking any classes in summer and you couldn't finish all this, try to finish everything by summer. And because my printer is not working, the quiz is only 1 page. I can look at the screen and then grade it, no problem. But the test has so many pages, you know, I will forget You know, it will be difficult for me to grade it. So if you can turn in the hard copy, I would really appreciate it. Outside of my door, there's a dark brown plastic box, just put it in there. Or my door is never locked, so you can open the door, put it on my desk, okay?
So the first step has been made on the last one. What we just.
Please, if you have the paper, yeah, it will really help me. Yes, please.
You wanted to attention to this?
No, just don't forget to put down your name and which quiz is that for. Write down the quiz number and then, your name. Okay? Someone had a question, just a second.
Oh yeah, where's your office so I can drop off the hard copies?
Gessner 311, you know where Gessner is?
Yes.
Okay, yeah, so it's in 311. It's on the elevator side.
Okay.
Thank you, yeah. Any other question? If not, if you didn't miss any test, I don't see you guys fail the class, okay? Unless you send me the blank test. Otherwise, I think the tests are very similar to the quizzes we did. So if you doesn't understand anything and everything is recorded, you can always go back to watch the video, okay? So let me stop the.
Oh. Where can I see the recordings? Because I can't find them for some reason.
Let me show you, let me